Hello, I'm Carmine from the Max Planck for Security and Privacy, and today I'm going to talk to you about an ongoing work in collaboration with Matteo Busi from the University of Pisa. And our work consists in comparing fully abstract and robust compilation. So let's start by looking closer at these two notions. By fully abstract compilation, we mean preservation and reflection of contextual equivalence. For a fully abstract compiler, two source programs, P1 and P2, cannot be distinguished by an arbitrary source context if and only if, after compilation, P1 compiled and P2 compiled cannot be distinguished by an arbitrary target context. On the other hand, with the term robust compilation, we refer to a family of criteria, but for the purposes of this talk, we will focus only on the preservation of classes of hyperproperties under adversarial context. In particular, we require that if a source program P robustly satisfies an hyperproperty H, meaning that it satisfies the hyperproperty in an arbitrary source context, then P compiled satisfies the very same hyperproperty H, but in an arbitrary target context. We are not the first to investigate the relation between fully abstract and robust compilation. It has been shown that fully abstract compilation does not imply any of the robust criteria, not even if one focuses only on one single hyperproperty, in particular non-interference. However, fully abstract compilation has been successfully used in the past 20 years, and some of the proof techniques developed to show that a compiler is fully abstract can also be slightly adapted to show some of the robust criteria. That's why we aim to investigate more the relation between these two notions and possibly try to reconcile them. As a first step, we put ourselves in a setting in which contextual equivalence that is a relation over programs, can be expressed in terms of execution traces that are instead collected by hyperproperties. So from now on, we will assume that the source and target language don't come with internal non-determinism. Under the disdeterminacy assumption, contextual equivalence can be replaced by trace equivalence. For robust compilation, we also slightly modify our requirement. We ask that if P robustly satisfies a hyperproperty H, then after compilation, P compiled robustly satisfies an approximation of the same hyperproperty that we model using a mapping between hyperproperties called tau tilde. We show that fully abstract compilation implies this variant of robust compilation parameterized with a mapping of hyperproperties tau tilde, for which we also set up an optimality condition. To sum up, we show that fully abstract compilation does imply some form of robust compilation parameterized by a mapping of hyperproperties tau tilde. We are currently trying to weaken some of the assumptions I mentioned before and provide a formalization in a proof assistant of this result. However, we explicitly notice that the mapping tau tilde is quite complex and not at all practical. Indeed, it requires to know the exact behavior of compiled program in arbitrary target context. So we are looking for other mappings between hyperproperties that can provide a less precise approximation, but can be easier to compute. Finally, we also notice that despite the optimality condition of tau tilde, it can still map an interesting hyperproperty like non-interference to a trivial one. So we are investigating condition under which non-interference is left unchanged by tau tilde, or at most just declassified. We thank you for your attention. We are happy to take any questions or suggestions for this work.